So finding the area of a parallelogram. First of all, I want you to write this somewhere. This is very, very important what I'm about to write. And I know I talked about it in the video, but I don't think I had you write it in this format. When you're taking the test on area or volume, and that's what we're going to be doing the next month. We're going to be doing area and volume. And it's going to get more and more challenging every single day, because every day builds off of today. That's why I said, some of you might think this is a little challenging right now. You won't after a while. You'll think it's easy. Trust me. Okay? There are 3 pieces to every area and volume question. Basically, I like you to think, I'm going to basically make it worth 3 points. Every area or volume question. Volume is until next chapter, but I'm just kind of getting you ready for that. Every area question for this chapter is going to be basically worth 3 points. Because I'm going to be looking for 3 things every single time you do an area problem. Okay? The first thing I'm going to look for is I'm going to look for a formula. I know that pretty much everybody in here has that formula memorized. And it's like, why do I got to write it every time? Well, when you write something enough times, you memorize it, right? And even though the word memorize doesn't usually work in math, when you're talking formulas and things like that, it does. It does work. So that's the first thing. We're always going to write the formula. Now the formula is going to change based on the shape that we're finding the area of. The second point of this is going to be the answer. So whatever you find the area to be, or if you're given the area, what the base or the height is. Okay? And the third point is going to be your units. Because remember, when we're talking about area, we always have to have units squared. Inches squared, feet squared. Very important. So let's think of it this way. Everybody in the class, as we just saw in the clickers, knew that this answer was 48. But I want to show you something. If you would just write 48 on number 1, if this were a test question right here, and you wrote 48, you just got 1 out of 3 points possible. Which means, you know what you got on this question? You got a 33%. That's an F, by the way. A low F. Okay, so even though, if you think about it, did you do the formula in your head? Sure you did. You got the answer, obviously. And then the units you didn't do, obviously, and that's -1. So you just missed 2 out of 3 points, and you actually got the most important part. Okay? Don't lose points for ridiculous reasons. Got me? So I will show you exactly what I expect, and I would expect you to go ahead and write this, unless you did it. So the first thing is we always write this formula. Base times height. Okay? Everybody got that? Okay. Next, I'm going to take that base and the height, which, by the way, let's talk about this for a minute, because this is something that students really get confused. I'm gonna color these 4 sides. So there's a red side. There's going to be a white side, really. What do I think? Okay, there's a green side. There's going to be a blue side, and then the black side. Somebody tell me, which side is the base? Which side is the base? Brooke?
Green side.
The green. How many of you would all agree that you would call this right here the base? This is one of these situations where the word in our language is kind of confusing what the word is in math. When we think of base, we think about the bottom of something. The base of my computer is the bottom, or the base of a TV, or the base of that desk. The bottom of it, right? But in math, remember, multiplication is commutative. So when I look at this formula, could I also write height times base? Isn't that the same thing? So I just changed the whole thing. So guys, it doesn't matter, because guess what? Ultimately, this figure right here, I'll just retrace it there. If I were to redraw it and I flip it over, or I look at it in a different way, is this now the base? So does it matter which side the base is? No. There's one key important part when we talk about identifying a base and a height. What is that importance? What is the importance of knowing a base and a height? They have to do something. There's something has to happen when you're talking about which one's the base and which one the height is. Do we remember from the video? This is pretty much the single most important thing about this entire chapter. So if you don't know, listen. The base and the height of every figure always form at a what kind of angle? A 90-degree angle. Okay? So that's why finding the area of rectangles is very easy, isn't it? Right, guys?
Yeah.
Because that's the definition of a rectangle. It's a special type of parallelogram that has all 90s. So right now, you know wherever this meets at a 90, the two sides that are connected at that 90, those are the right angles. Does that make sense? That's why rectangles are so easy. Okay? But when we went down to here, it gets a little harder, right? We go down to here, it gets a little harder because I can look at that. Is that right there a 90-degree angle? Is that? None of them are. So this is where you have to, that's where they get a little more challenging. When it's just a rectangle or a square, it's very simple. So going back up here, let's talk about the points that I would require. Again, I wrote my formula. Get rid of this height. Don't do that, by the way. Let's keep it as base times height, okay? Now I just go ahead and call my base and my height whatever. I'll just call this my base, this my height. So I know this is going to be 6 and 8. So I'm going to do 6 times 8. Now what is 6 times 8? 48. And then we know the area is inches squared. Volume would be cubed. So going back to my 3 points that I had us right up there. Did I get the first point, guys?
Yeah.
Did I get the second point?
Yeah.
Did I get the third point?
Yeah.
So, could somebody tell me, what does this mean? What is 48 inches squared? Fees?
That's the area of
That is the area, but what does it mean? I mean, I can tell you that it's got to have a meaning. Even?
It means like the amount of space inside the box.
You're getting closer. Specifically, and I'm going to ask you this a lot over the next month. We're going to really try to understand area and volume and not just be able to do it, but really be able to make real statements about what it really means. Yes?
48 cubes can fit.
Not cubes, because there's no cubes that can fit into a two-dimensional object, right? A cube is something I can hold in my hand. Can I hold a square in my hand? No. Do you guys understand that?
Yeah.
I cannot hold a square. That is, up there, I cannot grab that and move that. It does not have a third dimension. Everything I can grab has 3 dimensions. We'll talk more about that later. So it's the amount of squares. So basically, we got to know what type of squares, guys. And this is the type of squares that I'm talking about. Okay? This is going to be, since we're talking about inches, this is going to be a 1 inch by 1 inch square. Somebody quickly tell me, what is the area of that square right there? What is the area of it? Loren? 1 square inch. Makes sense, right? So if that's 1 square inch, in this whole thing, it'll take 48 of those to cover it. Does that make sense? That's what area is. It's how many 1 by 1 squares, or squares that have an area of 1 square inch, will it take to cover it. Does that make sense? If it doesn't, it will. Trust me. So understand the 3 parts here. 1, 2, and 3 right here. Okay, real quick. Let's do one quick practice one, okay? I'm going to say this is 3 feet. This is 2 feet. So that would make this 2 feet, and it would make this 3 feet. I would like everybody right now, please tell me the area of that figure. But I'm going to have you put it in your clickers. Okay, so now I'm going to pull this up. Let's see our answers here, guys. All right, so based on that question, find the area of it. We had one person that put 0. Not sure. I think I know what that person might mean. If it was somebody that I think it was, I don't know. Who had 0? Okay. We had 20 of you say 6. And we have somebody that put J6.
Oh, sorry.
I'm pretty sure. Surprise, surprise. All right, and then we have NP. Who put NP? So, Meg, I got to ask you, what did you mean by 0? Okay, so she didn't know how to do it. Okay. It's okay. At least you're close. I'm going to tell you right now, right there, my man is absolutely correct.
Why?
Not possible. We'll talk about why in a minute. Mega would be the next closest because she didn't know how to do it because guess what? You can't do it. It is absolutely not possible. Very nice. Good job. Let me explain why. I just spent the last 5 minutes before we did that question explaining to you that a base and a height must meet at a 90-degree angle. Guys, when you go to the doctor, when you go to get your height measured, you don't go like this, do you? Okay? You don't do that because you wouldn't. That isn't your true height. Your true height is standing up as tall as you can. What angle am I with the floor right now?
90.
90. That is my true base and height. So if obviously I'm not if I'd have to be like a rectangle. Imagine me being a rectangular shaped human being.
What?
Like SpongeBob. Alright?
He's square.
Oh,
He's called
Okay.
SpongeBob Square.
yeah, and that's a lie, by the way.
SpongeBob Square.
Stop it. Alright. Well, I call him SpongeBob Rectangle Pants.
He's
but
not
that's
a
just-
rectangle.
Okay. Alright, so, back to this, sorry. So guys, if I ever give you a problem like this, you should have known that's not a 90. So you can't just make that statement and you can't say, oh, well that right there is, where'd it go? That's the height. That's not the height. That's not the height. Sure, you could call this the base, but the answer here is this is 100% not possible. You can't do it. So congratulations to both Mega and Ethan because they were the closest to the answers. If I'm calling this my base, if I'm calling 3 feet my base, then what my height is it is the distance to the base that's parallel or the one that's across from it. So I would have to actually measure from right there to right there. And notice how it comes right at a right angle. It's a right angle at both the bases. Or I could do it on the outside. Would you agree that everything I have right there to there, is that the same distance?
Yeah.
What about from there to there?
Well, we have to
What about from there to there?
Like if the test we have to like measure.
Yeah, yes.
No,
I could put this on a
no,
test.
no, no.
Number 2.
Okay, never mind.
Okay, as you can see, this one didn't do that to you. I could have, if this was 1.5, it'd be not possible. But guess what? It actually gave us this height the right way. So the first point would obviously be to write the formula. That's point number 1. Point number 2 is to actually multiply the base and the height. Now, people get confused on why. This is easy. You guys all got this right because there are only 2 numbers there. But I guarantee you, if I would have also put 2 right there, there would have been some people putting 8. But when there's just 2 numbers, you guys just assume, oh, that's got to be right. But why is it? Well, look at it. Sure, they went on the outside of the figure, but is it still coming down at where that would be at a right angle, guys?
Yeah.
Yeah. Now, could they have also done it just right here?
Yeah.
So why did they do it outside? I don't know. It's just the way I found it. It was like that. I could do it anywhere. I could extend the top up here, and then go here, and then find my right angle there. Either way, it's the same distance. It's the distance between the parallel bases. Got that?
Only 4 points you can do.
Yeah. So basically, I know that it's going to be 1.5 times 4, or 4 times 1.5. It doesn't matter. Okay. You're going to end up getting 6. That's the second point. And then the final point would be yards squared. So what does that mean again? Well, that means that there would be 6 of those 1 yard by 1 yard squares that it would take to cover that. Okay, number 3. This is where it gets a little bit more challenging. Now look. Obviously most of us, we all call this the base. Right, guys? We call that the base. Right, everybody? And again, the word base in our language means bottom. So you guys just assume it's the base, but you could call this the base and figure out the height going the other way. But that would make it a little more harder than it needs to be. So people get confused. They say, well, do I count that square? It's not about counting the squares. It's about counting the bottoms of the squares. From right there to right there, do you agree that's 1 unit? 2 units from there to there. 3 units, 4 units, and 5 units. So I know that this has a base of 5. Well, now I can't count diagonally. That doesn't work. So guess what? I got to figure out, I got to go straight up. Okay? Right here, straight up. And there we go. There's my 90-degree angle. Could I have done it there too? Could I have done it there? 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 Absolutely. It doesn't matter. Could I have done it there?
Yes.
So I know that those are going to be the same. So what's the height there? It's going to be 3. So again, hang on, guys. I'll get your question in a minute. Okay, and that's going to be 5 times 3 is 15. Now there is no yards, feet, inches, or meters here. So what do we put?
2.
Units squared. Okay. Yes, questions? Next one. This one was, again, kind of challenging because it didn't line up exactly on the lines. But what I did is I just imagined, okay, if you move this whole thing up a little bit. Here, let me just do it real quick. If I just kind of trace this. Yeah, I know. Alright, and then moved it kind of up like that. Isn't that more realistic? Yeah, and now if I'm getting my height there, I can see that the base would be 1, 2, 3, 4. And my height would be, and I can do it on the outside too, 1, 2, 3, and 4. So 4 by 4. Is that what the answer is?
No.
Was it 20?
Yeah.
So I'm 1 off because it's because of the way it's drawn. It's weird. 1, 2, 3, 4. Oh, it's 5. Yeah. All right, so it's going to end up being area equals base times height. 5 times 4 is 20 units squared. All right, last one here. Now notice, I know that a lot of you probably just said, oh, 54 divided by 9 is 6, so I know it's 6. I'm not going to accept it, guys. Remember, everything that I've taught you this year is about a process, not necessarily about an answer, right?
Yep.
I still expect these 3 pieces right here to work down here. And let me show you what I expect. I expect you to write the formula. That's a rectangle, so we do base times height. Okay? Now, the difference here is, normally we know a base and a height, but this time we actually know the area. 54 equals 9, and then the height is x. Right, guys? Do you guys know how to solve equations? Undo it by dividing by 9. That's x equals 6. See how we get right back into... I expect you all to do it just like that. That's the way I want you to get in the habit of doing these things, okay? Everybody got that? Understand that?